Good day everyone. Today I'm going to be going over circuits. So I'll be going over parallel circuits, I'll be going over series circuits and how to handle them when they're combined. Just the general overview of the rules that you need to know for how to deal with them. This is going to be relevant all the way from grade 10 up to matric. This is still going to be tested in your final matric exams. So the stuff stays the same basically. In grade 11 there is some extra stuff, and in grade 12 there is some extra stuff, but this is the foundation, and there's still going to be questions that you as a grade 10 could answer even in matric. There'll still be elements that are pretty much exactly the same. So a parallel circuit, as I believe you know by now, a parallel circuit is a circuit that usually looks something like this. So your batteries are parallel to each other, so they lie alongside each other. They're on different branches. Okay. And so there's a few rules when your circuit is parallel that you need to kind of remember. So whenever we're talking about these circuits, we are going to be talking about three things. We're going to be talking about the voltage, we're going to be talking about the current, and we're going to be talking about the resistance. Okay, and so whenever you're finding out any of these, the type of circuit is going to be relevant. It's always going to come up. So in a parallel circuit like this, you're going to have a situation where your current is going to split across the different branches, but your voltage is going to be the same everywhere. So let me explain this. So how I like to remember it, I think of the circuit like it's a stream, like it's a river. And I think this is when you come across a split in the river, the current, which, you know, rivers have current, the current is flowing down the river, and when the river splits, then the current also splits. So when the split happens, over here the river is dense, there's a lot of water moving by, a lot of current, but if the river split somehow, then each of the little branches gonna have a lot less current. So your current splits apart. And then when they join back up together, your current is gonna be great again. So you're gonna have a lot of current over here. So that's how I like to view this. Your current is what splits when it's a parallel circuit, because you've got these different branches. So that tells us that your total current is going to be your current 1 plus your current 2 plus current 3, whatever. But all of the currents of these different branches, you add them all together and that's your total current. And your total current is over here. So that is how your current works. So your current is going to split. However, your voltage is going to do the opposite. So your voltage is going to stay the same everywhere. So each of these branches is going to receive the same amount of voltage. So your voltage total is going to be your voltage 1, which is equal to your voltage 2. So if you've got voltage here, voltage there, if you measure it anywhere, it's all going to be the same. The final thing is resistance, and to calculate your resistance, the formula that you need to know is your 1 over your parallel resistance is equal to 1 over R1 plus 1 over R2. This is how resistance is calculated. So your steps are, so let's say the resistance over here is 5 and let's say the resistance over here is also 5. Okay, I'm illustrating these resistors as light bulbs. As you get later on into school, you might see them displayed more often as just little rectangles. These are just resistors, but they work exactly the same as these little light bulbs do, so don't let that frighten you. But yes, so we've got the resistance of each of these resistors. So if we wanted to work out your total RP, you do 1 over your resistor 1, so 1 over 5 plus 1 over your resistor 2, so that's 1 over 5 plus 1 over 5. So if you add that together, you have to look for lowest common denominator sometimes. So if they were different, you need to make sure the denominators are the same. So this is just a maths trick. But in this case, 1 over 5, they're both the same, so you'll get 2 over 5. Okay, so that tells us 1 over RP is equal to 2 over 5. So therefore, RP, you just need to flip it around, and you'll get 5 over 2. Okay, or in other words, 2.5 ohms. Okay, so you must be careful in this section not to just say it's going to be 5 plus 5, it's going to be 10. You can't just go and say your RP is going to be 10 because both of these are 5. It's not that simple. It's actually 2.5. So you need to do this the proper mathematical way. This is somewhere where it's a little bit dangerous to skip steps because you might mess up. So yeah, do it this full way. Okay, so as you can see, we've got two resistors that are both 5 ohms, and our final resistance is 2.5. So our total resistance in this case is less than all of our resistors. So what would happen if we took this one at the bottom away? If we had a very basic series circuit like this. If you had a very basic series circuit like this, then your total resistance is just 5, right? That's your total resistance. So as you can see, we went from 5 to 2.5 by adding more resistors. So if we put that resistor back, then our resistance is gonna decrease. So this is what's weird about resistance in a parallel circuit, is that the more resistors you have, the lower your total resistance is gonna be. So these rules are most useful when you use it alongside your V is equal to IR formula. So you mustn't just think I can only use these rules or I can only use this formula, because they're constantly used at the same time. So I find it's a good idea when you come into a question paper to write down these rules, maybe to remind yourself at the start, okay, it's a parallel circuit, so in parallel I can remember that my current splits. So my current is equal to I1 plus I2, and your voltage is going to be the same everywhere. So writing down these rules might be a good way of being able to remember them during the test, so that you don't stress yourself, you don't get mixed up, especially when it comes to the more complicated circuits. So questions where you might use this is if, let's say, they told you the voltage over here and they told you the resistance over here, and you needed to figure out the let's say the current over here, then you would make use of the fact that you know that this voltage would be the same as the voltage down here. And down here, you've got your V, you've got your R, so that's how you can work out your I. So sometimes you might need to bring information from other parts of the circuit to help you complete the whole circuit equation, to figure out whatever you're trying to figure out. You might also need to figure out your totals. So you might want to figure out your total V, and this is easy in this question because you just need to figure out your voltage of one branch and it'll be the same as your total voltage. Or maybe you need to work out your total current. So in that case you might need to work out your total current by adding the currents of both of them. But also another way to figure it out is work out your total V first, work out your total R first, because you know your formula over here, and then you can work out your total I. So in these kind of questions there are often multiple solutions, and so writing down the information and writing down what you know so that you're sure you're not messing up is a good way of helping you solve it. Having the tools in front of you can make the solution seem a lot more obvious. So let's talk about a series circuit. So in a series circuit, if you were thinking of the current again, you can think of the river. The current never actually splits. The current follows the same flow of the river the whole way, and so because the current never has to split, your current is the same everywhere. Whereas your voltage is what gets added up. So your voltage is gonna not be equal to each other, but it's going to be the sum of each of the individual voltages. So if you'll notice, these rules are the opposite of the parallel rules. So in parallel, your voltage is the same everywhere and your current changes, whereas in series your current is the same everywhere and your voltage changes. So you need some way to think of to make sure you don't get those rules mixed up. I had a teacher who explained it to me with a different metaphor. So she thought of this as a factory providing bricks to different buildings. So the factory produces trucks and all of them have bricks, and in a series circuit, so your bricks are your voltage and your truck is your current. And so in a series circuit, as you go by, this truck is going to have to pass by all of these houses. This one truck passes by all of these houses, and so it has to share the bricks with each house that it crosses by. So the truck distributes the bricks, but then the same number of trucks go past every house. So this house and this house will see the same number of trucks drive by. Whereas in a case like this, those trucks are going to have to split up. So the houses will have different trucks running by them, different current. But each house, since it's all alone, will receive all of the bricks of the truck. So they'll receive the same amount of bricks per truck, and so they receive the same voltage, but they're going to have a different number of trucks driving by them. So whatever metaphor works best for you is what you should make use of, as long as you find some way to remember these rules. Okay. Finally, calculating your resistance in a series circuit is very simple. It's just your total resistance is equal to all of your resistors added together. So the more resistors you add, the higher the resistance will be. When you see this in your final papers, it's not going to be that simple. It's going to be a combined example like this. So in this example, you can see there's a cell over here and there's two cells over here that are in parallel. And so is this a series circuit? Is that a parallel circuit? It's a bit harder to tell. So when you see a question like this, you need to break it up. Break it up into an outer circuit and an inner circuit. So this circuit I'm going to call the inner circuit. And this circuit, so if you just looked at this circuit alone in a box, you would say that's parallel. And so treat that circuit somewhat separately from the rest of the equation. You can treat that circuit over there like its own little parallel universe, its own little parallel circuit universe. And then the outside will affect it. But how the outside will affect it, the outside will affect the totals. So you can treat the totals of the circuit once you calculate them, your total voltage, your total resistance, even your total current, all of them, you can treat them in this outer circuit like it's just another resistor. So you can kind of imagine redrawing the circuit a little bit more basically. So it's like we just took this circuit over here, this circuit, and we treat it like it's a resistor in of itself. And so now you can see the outer circuit is definitely series. And we know that secretly this resistor over here is actually a parallel circuit in of itself. But you can treat your total voltage, your total resistance, your total current as if they're just the voltage, resistance, and current of this resistor. So sometimes you're going to want to work your way from the smallest bit into the wider circuit. So you'll work out this information first and then use it in this outer circuit. Sometimes it may be the other way around though. So sometimes you might make use of this outer circuit and your series rules to figure out your total voltage or your total resistance, your total I, your total current, and you will use those values. So you go from the outside and now you go in and you look inside this smaller circuit. You use these values as your totals and you can use those totals to find out the values specific to the real actual resistors in this circuit. These questions can seem scary and they can seem big and daunting, but just by breaking it apart like this, you can make it a lot more manageable. Another type of mixed circuit that you could get might look something like this, where you've got an inner series circuit and an outer parallel circuit. And so the same logic applies. You can treat it like two separate circuits. Treat the branches separately and treat this combined series circuit like it's its own resistor. And the totals of this circuit are the properties of that resistor. And then you can go from the inside out or from the outside in. But again, it's not too complicated. You just need to keep that in mind. Treat them like two separate basic circuits because you know what to do in these basic circuits. And so if you think of it like that, if you think of it in terms of what you know, then it seems a lot easier than if you just look at it all in one picture. Then it can seem overwhelming and impossible. So just take it slow, and you can do it. Alright, I'm going to end the video there. I hope that was helpful to you. If you have any questions for me, or any requests for what I should cover next, then please leave a comment below. If you enjoyed the video, then like and subscribe. I would really appreciate the support, and it would encourage me to keep creating these videos. If you want to contact me for private tutoring, then look in the description for the link to my website. But more than anything, thank you for being here, and remember, you're smarter than you think.